Today we are going to be working on module 5.3, and this is about scatter plots and lines of fit. And so look at our learning target. I can categorize the correlation of a set of data in a scatter plot and make and evaluate predictions by fitting linear functions to sets of data. So this module has a lot of new vocabulary. So let's look at what the vocabulary is. We have bivariate data, and bi basically means what? Two, right? And variate is basically another word for a variable. So two variables, and that is what this data is about. And so bivariate refers to a statistical analysis that involves the comparison of two separate variables. All right. So for example, we can say data collected from a study that is comparing the level of anxiety to the number of times a participant is pacing back and forth. So these are two different things, and so that is basically what it is. Or I could say the number of days you are missing school, for example, and how it is affecting the math grade. So these are two different variables. So that is why it is bivariate data. Okay, so now we also want to talk about a scatter plot. But again, a bivariate data consists of pairs of values, and a scatter plot is a graph of a bivariate data that consists of ordered pairs on a coordinate plane. So we'll talk about the trend, correlation coefficient, a line of fit, linear extrapolation, and linear interpolation, and outlier. So let me take you to my whiteboard where you can get an example of what a scatter plot looks like. And here is an example of scatter plots. Okay, so once again, what is a scatter plot? A scatter plot, it is a graph, as we can see, of bivariate data that consists of ordered pairs on a coordinate plane. So if you are looking at this, it looks like they are just clumped, or they are clusters like this together. Okay, so when the clusters are going upwards together, we can see it's a positive correlation. And as x increases, y is increasing. Let's say the more number of hours you are studying, your math score grades are better. So two different, but it's kind of affecting each other. So again, those are as x is increasing, y is also increasing. Okay. Now, negative correlation, as you can see, it is going downwards. As x is increasing, y is decreasing. And then we have no correlation. There's nothing over here that's telling me whether it's an upward trend, downward trend. It's all over the place. Okay. Another thing that I want to show you really quick, like let's say if I have an outlier, now we can see that most of this, it's going in this direction. But I might have a number which is way out of there, which is nowhere in that upward trend that is moving. Okay, so if I have a plot over here, see this one here, this will become my outlier. This is my outlier. It is there in the graph, but again, the trend is not really affected, but it shows me where the outlier is. Okay, and so when I look at a scatter plot, and when I am plotting it later on, you can have more than just one line that is going through the plot. Okay, so we are trying, and that's where your correlation coefficient comes in. So I just want to give you an example. If I am drawing a line through this, a line can go through the points like this. Okay, we can also have a line that is going this way or this way. So guys, a scatter plot can have a lot of lines, but then we are trying to make a line which is going to go to the maximum and through which most of the clusters are around when we start calculating that in a minute. Okay, so, and what the trend is. So I just want to show you that in a scatter plot we can have multiple lines that are graphed. Okay, but then again, I think based on my graph, this line would be the best suited, which is the middle line over here, because it's going through most of the points. Okay, so now having seen this, let's quickly talk about the correlation coefficient. Okay, so I'm going to show you a picture. So let's look at this one, correlation coefficients. Okay, so when I'm looking at correlation coefficients, I can see that my graph can be a perfect negative correlation. Look, if it's like a straight line kind of going down, and if I'm plotting a line, it's going to go straight through, right? So that's a perfect negative correlation. And on the right, extreme right, I'm going to have a perfect positive correlation. And everything else is going to fall in between. Okay, so everything else is going to fall in between. So as you can see over here, there's no correlation. There's no downward trend, no upward trend. There's no correlation over here. Okay, and so this is like, okay, if I have a trend, it's not closely clustered together. Okay, so that line is going to be a little bit, either you can draw it this way or that way, but it's not a very strong, correlation. Over here, it's getting closer together. So it's getting stronger. And then this is the strongest because this is a perfect positive correlation because all the dots are falling in about a straight line. And then the same is true backwards for the negative. Okay, so there's a certain rule that applies to correlation coefficients. Okay, and we are going to look, see, it falls from -1 to 1. And -1 is the strongest negative correlation. It's a perfect one. And 1 is the strongest or the perfect positive correlation here. And then everything else falls in between. So if I do 0.4, 0.6, 0.8. Okay, and then same thing on the other side. Here. Okay, so if I have this like this, I needed to understand that it is going to be strong if it's above this part. If it's above 8/10 to 1, this is a strong correlation coefficient. Okay, so this is strong. All right, and moderate is when here, if this is 4/10, this is my 5/10, right? So if it falls between 5/10 to 8/10, this part, this is moderate. Okay, and then if it is falling below, so if it falls below 5/10, this is a weak correlation. All right, and then as it turns in this direction, the same thing happens. This is weak, and then we have from our 5/10 and here to 8/10. This is going to be, this is -5/10 to here. This is my moderate. And then here, this is my strong. Okay, so It could be strong towards the perfect negative correlation, and that is going to be strong towards the perfect positive correlation. So this is a rule of thumb to follow when you're trying to see if the correlation coefficient is weak or it's strong. As you can see over here, there is absolutely no correlation. Everything is all over the place, right? And then it starts going towards those perfect lines to the left or to the right, showing a strong correlation. So this is one thing I wanted to show you before we moved on. So let's look at this question. It's asking talking about evaluating correlations, and we're talking about football. The scatter plot displays the height and weight of New Orleans Saints football players. Determine whether the scatter plot shows a positive, negative, or no correlation. If the correlation is positive or negative, describe its meaning in the situation. So let's look at this graph. Okay, now we can see that this graph is going upwards. It's going upwards, right? So it is showing a positive correlation, and it's saying, and when we're talking about the meaning in the situation, so as the height of the football players increases, the weight also usually increases. And that's what this means. Okay, let's look at another one. Here is telephones. All right, so the scatter plot of the scatter plot displays the number of landline telephones in the United States in 100 millions since 2000. Determine whether the scatter plot shows a positive, negative, or no correlation. Describe the correlation's meaning in the situation. So if I'm looking at this, what do you see? That I see that there is a decline. So this is going to be, it is showing what kind of the correlation? This is a negative correlation because it is going downwards. And so as time increases, the number of landlines generally decreases. And that's what this correlation means. All right, so let's talk about what is a line of fit. Okay, a line of fit is nothing but is describing a trend of the data in the scatter plot. So we are now going to go ahead and create a scatter plot using this data here. And then we'll talk about the steps involved in creating a scatter plot. Okay, so it's talking about boats. The table shows the average cost of a jet boat in the years after 2000. Write and interpret an equation to represent the data. Then use the equation to predict the cost of a jet boat in 2005 and 2025. So now these values are given to me. So the first thing that I'm going to do to create a scatter plot is I am going to graph this. Okay, and so yes, I'm going to have x and y, so that's my ordered pair, and I am going to go ahead and first plot these into the graph, and then we're going to determine whether any relationship exists in the data. All right, and then I'm going to draw a line that closely follows the trend in the data. And so after that, what I'm going to do, I'm going to use 2 points on that line. I'm going to try to find one which has a perfect intersection with x and y, and then I'm going to take another point in the line that is following the same trend. So I'm going to take 2 from that line. And then I am going to, using the slope and a point of the line, I'm going to create an equation for the line by finding the slope of the line, and then I'm going to create an equation once I have found the slope. And then after that, I'm going to use the equation of the line of fit to make predictions about the unknown data. Now, I want to talk to you really quick about linear extrapolation and linear interpolation. So, linear extrapolation is the use of a linear equation to predict values that are outside the range of data. So we're predicting values for those which are outside the range of data, and that is extrapolation. And then we are going to talk about linear interpolation. It is the use of a linear equation to predict values that are inside the data range. So extra and inter. Okay, so extrapolation outside the data range, interpolation inside the data range. Okay, so I'm going to go ahead and show you the graph that I've already created using these values in order to save us time. And we know this is x, y, x, y. So we're going to go ahead and just create a graph based on these values. Okay, so but of course you will have to create that graph. So here is a graph that we have created using the values. Okay, so this is a graph that we have created using the values over here. So as you can see, we have the independent variable is the number of years, and I've always told you time is always x, so it's the independent variable. And then we have and the dependent variable is the cost of a jet boat. And as the years increase, the cost of a jet boat also increases, as we can see, because it's an upward slope. So this is a positive trend going on. So this scatter plot shows positive correlation. Okay, so now let's look at this, and we are going to take 2 points. We have drawn the line as close to the trend as possible. And what I'm going to do is I am going to take 2 points from here. Okay, so let me take, well, this is pretty close here. So I'm going to take 5, and let me take another one, which I can take is 10. Okay, so I'm going to take these 2 values over here to create. Very often, actually, a really good thing to do would be that if it's falling exactly like this, this would be a good one to take, 3 and 20,000. Okay, but right now we've drawn the line like this, but it's good to have it at the intersection. And then we can take another one, which is, but this is slightly lower with the line, and that's the reason I am not taking it. But otherwise, this would be a good one to take to compare. Okay, so anyway, so let's take the line of fit. It passes close to the data points, and I am going to now start solving it. So I'm taking the 2 values, and I am taking 5 and 25,108. Okay. All right, so these are the values I've taken for 5. For 5 I have 25,108, and for 10 I have 32,752. And then I'm going to go ahead and I am going to find the slope. So we have m is equal to y2 minus y1 over x2 minus x1. Okay, and so I'm using the slope formula. And so what do I get? I get, what is y2 is 32,752 minus 25,108 over x2 is 10 minus x1 is 5, and I get 7,644 over 5, and that gives me 1,528 and 8/10, and that is my slope. Okay, now normally in most cases, if I have a slope like 3/2 or 2/3 or 1/4, so I know it is like rise over run, right? We normally leave it in that form. But in scatter plots, we can convert it. This is one of those cases where we can convert it to the decimal format. Okay, so now I have found the slope of this. And then the next thing I'm going to do is use the point slope formula to find the y-intercept. And my point slope formula, we have, let me use a different color so you can see better. Okay, so I have y minus y1 is equal to slope x minus x1. So this is my point slope formula. Okay, and I am just going to now substitute the values. Let me take this. You can take one of the ordered pairs. And so I do y minus 25,108 is equal to, what is the slope that I found? It is 1,528 and 8/10 x minus, what is my ordered pair for x? Here's 5. So this is what I am solving now. Okay, and then I am getting, we are going to do the distributive property, right? So I get y minus 25,108 is equal to 1,528 and 8/10 x minus, I get times 5, and I get 7,644. And then what am I doing? I am going to be adding 25,108 to both sides of the equation. 25,108. And so I'm left with, this is gone, y is equal to, and I get 1,528 and 8/10 x plus, because I'm subtracting this from here, I get plus 17,464 as my y-intercept. So here is my equation that I am solving using this graph. Okay, so I'm going to now evaluate this, and then let's look at this. And it's saying use evaluation to predict the cost of a jet boat in 2005. Since the independent variable represents the number of years after 2000, the value of x is 2005 minus 2000, or 5. So therefore, all I'm going to do is substitute the value of x, and I am going to do this times 5. Okay, so I'm going to do 1,528 and 8/10, and instead of x, I'm just going to say times 5 in order to do the calculation. And so when I simplify, I get 25,108. And so this is my final answer once I substitute that x value with 5. So once again, let me explain this. So we are saying we are evaluating because we are predicting the cost of the boat in 2005. Okay, and we are talking about since the independent variable is what? The number of years after 2000. So what is 2005 minus 2000? That gives me 5. And that's why I have substituted the value of x with 5 in order to find out what the value of the boat will be in 2000, or was in 2005. And so we can predict that the cost of a jet boat in 2005 was about 25,108. And after that, we can predict the cost in 2025. And the cost in 2025, what would we take? The same thing again, and we would substitute the value of x. What would this become now? This would be times 25. If I'm doing it for 2025, right? Because that is 25 years from 2000. So if I multiply with 25 over here, I'm just substituting the x value. I am going to get 55,000. I'm going to get 55,684 once I simplify. So this is in 2025. This one was in 2005. Okay, so that's basically how we can predict the cost of a jet boat in 2025 will be about 55,684. Okay, so let's do another one really quick. And here's one. We are talking about animals. Okay, so the data shows the amount of milk that a baby goat needs by its weight. So we've got the weight in pounds and we've got the milk in ounces. Okay, so this is my independent variable and this is my dependent variable. This is going to go on the x-axis, this is going to go on the y-axis. So I'm going to go ahead and show you the graph and then I will show you how to write out an equation. Okay, so here's the graph that we have created. Okay, now, so let's look at this. And what I'm going to do over here is I am going to take what I was talking about earlier. That's what I wanted to show you. I want to take a point on the graph which is like completely in sync with, here. Let's look over here. So I want to take a point on this graph that is absolutely here. Look, this right here. So it becomes very easy for me to see that. So if I take this graph, I'm going to go ahead and I have another. So when I am plotting this, I want to look at 2 points which are at the intersection. So it's very easy for me to visualize what points I'm taking. I know the previous one was a little bit harder because, but we're going to take 2 and you want to do that too. So take a point here. Sure, I can take this also. Okay, I can take 25 and 40, but I can also take 50 and 80 over here. So look how this is going this way. So I'm going to go ahead and take these 2 points because this is like going to be easy for me to calculate. And that's what I was trying to say earlier when I was talking about take points which are easy to just, read. So I'm going to take my ordered pairs, which is 10, 20 and 50, 80. Okay, so what's the first thing that I need to do? I need to find the slope. So m, which is slope, is y2 minus y1 over x2 minus x1. Okay, so this is x1, y1. This is x2, y2. Okay, and so what is y2 over here is 80 minus 20. 80 minus 20 over 50 minus 10. 50 minus 10. And I get 60 over 40. Okay, and when I simplify here, I get 6 over 4, which is 3 over 2, which my slope is 1 and 5/10. And then once I have got my slope, I'm going to use the point slope form and I am going to do y minus y1 is equal to mx minus x1. And that is my point slope formula. And then I'm going to go ahead and take the ordered pair, this one, to put in values over here. So this is y minus y1, which is 20. My slope is 1 and 5/10 x. 1 and 5/10, and then you have x minus x1, which is 10. Okay, and then I'm going to simplify and I'm going to do the distributive property over here. So I'm left with, here I'm going to do it here. Okay, I'm left with y minus 20 is equal to 1 and 5/10 x minus 1 and 5/10 times 10, and that gives me 15, right? And then I am going to do the inverse of subtraction, which is addition. So this is plus 20 on each side of the equation, because whatever I do on one side, I have to do the same thing on the other side. Okay, and so 20 minus 20, I have 0. Y is equal to 1 and 5/10 x plus 5. And so this is my equation. This is my equation in my slope-intercept form. And then we can use this equation from part A, to predict the amount of milk needed for a 17-pound goat and a 55-pound goat. So then what am I doing? I'm just substituting the values. And when I substitute the values using this equation, I am going to get 30 and 5/10 ounces for this one. Remember, I'm just substituting the value of x. And then in the other one, for 55-pound goat, I am going to get 87.5 or 87 and 5/10 ounces. Okay? All right, there's one last thing that I would like you to see before we finish our lesson today. All right, so let's look at this over here. We've got two scatter plots. Actually, this one is the same as that one. Okay, so we're talking about which type of correlation is best illustrated by this scatter plot. So the first one, is there an upward trend? No. Is there a downward trend? No. This is all over the place. So this one over here, there is no correlation. No correlation. This plot. Okay? So which is the most accurate line of best fit for the scatter plot? So if you look at this, well, I would have to say we are going this way. This one, because it is going upwards, okay, so this one, which is what? Which is going to be line C, would be the best option for this one. Okay, all right, let's look at one last thing. And over here. So if I am looking at this, we're talking about when writing an equation for a line of best fit, you pick 2 points. Are they from the table of points? Are they from the points on the scatter plot? Do you pick points from the line? Or include the origin and one other point on the scatter plot? So as you saw, we were looking at the line and we were picking the points on the line. We were trying to find those points which are falling in the perfect intersection for us to be taking a point like that. So therefore, what is the answer on this? We are picking the points on the line. We're not looking at the table. We're not looking at all that. We are looking at the trend and then we are picking points from the line. Okay? And that concludes our module 5.3. Scatter plots and fit, and we learned a whole lot of new vocabulary in this lesson. And then anyways, the next lesson also is going to be connected to this one. And so that concludes module 5.3. Have a fantastic day, everyone.